The planets of our solar system are awash in sound, but not in the way we hear it on Earth. Sound waves cannot travel through a vacuum, so the sounds of the planets are created by other forms of energy, such as radio waves, plasma waves, and magnetic waves. NASA scientists have used specialized instruments on spacecraft to record the sounds of the planets. These recordings have helped us to better understand the physical processes that are taking place on the planets, and they have also given us a unique perspective on the beauty and wonder of space. NASA records the sounds of planets by using specialized instruments on spacecraft. These instruments detect radio waves, plasma waves, magnetic waves, gravitational waves, or shock waves, which are all forms of electromagnetic radiation. The waves are then converted into sound waves that can be heard by humans. Here are some examples of how NASA has recorded the sounds of planets. The Sun. NASA did not record the sound of the Sun. Sound waves cannot travel through a vacuum, and the Sun is surrounded by a vacuum. However, in 2018, NASA released a sonification of the Sun's vibrations. Sonification is the process of converting data into sound. The sonification of the Sun's vibrations was created by scientists at the Stanford Experimental Physics Lab. The sonification was created by assigning different pitches to different frequencies of vibration. The result is a sound that is often described as being like a deep humming or rumbling. NASA has not recorded the sound of Mercury. Sound waves cannot travel through a vacuum, and Mercury has a very thin atmosphere, so there is no way to record the sounds of Mercury from space. The only way to record the sounds of Mercury would be to send a spacecraft with a microphone to the surface of the planet. However, the temperatures on Mercury can reach up to 800 degrees Fahrenheit, which would melt any microphone that was sent there. NASA scientists used a different method to record the sound of Venus. NASA has recorded the sound of Venus, but not in the way that we hear sound on Earth. Sound waves cannot travel through a vacuum, so NASA scientists used a different method to record the sound of Venus. In 2020, NASA's Parker Solar Probe made a flyby of Venus. The Parker Solar Probe is equipped with a variety of instruments, including a magnetometer and an electric field sensor. These instruments detected a natural radio emission from Venus's atmosphere. Scientists were able to convert this radio emission into sound, and the result is a strange, eerie noise. The sound of Venus is a reminder that the planets in our solar system are very different from Earth. It is also a reminder of the power of science and technology to help us understand the universe around us. Now listen the sound of the Venus. NASA has recorded the sounds of Earth's atmosphere. The Van Allen probes, a pair of spacecraft that study Earth's radiation belts, have recorded the sounds of plasma waves in Earth's atmosphere. These plasma waves are caused by the interaction of solar wind particles with Earth's magnetic field. The Van Allen probe's instruments convert the plasma waves into sound waves that can be heard by humans. The sounds of Earth's atmosphere are very different from the sounds we hear on Earth. This is because the sounds are created by plasma waves, which are a type of electromagnetic wave. Electromagnetic waves do not travel in the same way that sound waves do. They can travel through a vacuum, and they can bend around objects. The sounds of Earth's atmosphere are often described as being like a high-pitched whine or a crackling noise. They are very faint, and they can only be heard with the most sensitive instruments. Here is the sound of our home planet. NASA has recorded the sound of Mars using the Perseverance rover's SuperCam instrument. The SuperCam instrument has a microphone that can record sound waves in the Martian atmosphere. The Martian atmosphere is much thinner than Earth's atmosphere, so the sounds of Mars are very faint. NASA has released a number of recordings of the sounds of Mars. These recordings include the sound of the Martian wind, the sound of the rover's wheels driving on the surface, and the sound of the rover's laser hitting a rock. The recordings of the sounds of Mars are a reminder of the power of science and technology to help us understand the universe around us. They also give us a unique perspective on the beauty and wonder of the red planet. Here is the sound of the red planet Mars. NASA recorded the sound of Jupiter using the Juno spacecraft's WAVES instrument. The WAVES instrument is designed to measure radio and plasma waves detected in Jupiter's magnetosphere, the bubble of charged particles that envelops the gas giant. The WAVES instrument detects radio and plasma waves across a wide range of frequencies. The waves are then converted into sound waves that can be heard by humans. The sound waves are amplified and processed so that they can be heard clearly. The sounds of Jupiter are very different from the sounds we hear on Earth. This is because the sounds are created by radio and plasma waves, which are a type of electromagnetic wave. Electromagnetic waves do not travel in the same way that sound waves do. They can travel through a vacuum, and they can bend around objects. Here are the sounds of the planet Jupiter. NASA scientists used a different method to record the sound of Saturn. The Cassini spacecraft's radio and plasma wave science instrument detected radio emissions from Saturn's magnetosphere. These radio emissions are caused by the interaction of Saturn's magnetic field with the solar wind. The instrument converted the radio emissions into sound waves that can be heard by humans. The sounds of Saturn are very different from the sounds we hear on Earth. This is because the sounds are created by radio emissions, which are a type of electromagnetic wave. Electromagnetic waves do not travel in the same way that sound waves do. They can travel through a vacuum, and they can bend around objects. The sounds of Saturn are often described as being like a whooshing or a hissing noise. The sounds are very faint, and they can only be heard with the most sensitive instruments. The recordings of the sounds of Saturn are a valuable tool for scientists. They help scientists to better understand Saturn's magnetosphere and the processes that create it. The recordings also help scientists to learn more about the interactions between Saturn's magnetic field and the solar wind. The recordings of the sounds of Saturn are a reminder of the power of science and technology to help us understand the universe around us. They also give us a unique perspective on the beauty and wonder of the ringed planet. Here is the sound of the ringed planet. NASA scientists used a technique called sonification to convert data from the Voyager 2 spacecraft into sound. Voyager 2 passed by Uranus in 1986 and collected data on the planet's magnetic field, plasma, and radio emissions. Scientists used this data to create a sonification of Uranus, which is a way of representing the data in a way that can be heard. The sonification of Uranus is a complex and eerie soundscape, with a mixture of low, rumbling tones and high-pitched squeals. It is thought that the sound is caused by the interaction of Uranus's magnetic field with its atmosphere and rings. It is important to note that the sonification of Uranus is not a literal recording of the planet's sound. It is a scientific visualization of the data that Voyager 2 collected. However, it gives us a unique and fascinating way to hear what Uranus might sound like. The sonification of Uranus is a powerful tool that can help us to learn more about the planet and its unique environment. Here is the sound of Uranus. In 2020, NASA released a sonification of Neptune's magnetic field created by the Voyager 2 magnetometer data. The sonification sounds like a deep, rumbling noise. It is important to note that this is not an actual recording of the sound of Neptune, but rather a representation of the magnetic field data. NASA is currently planning a new mission to Neptune, called the Trident mission. Trident is scheduled to launch in 2039 and arrive at Neptune in 2049. The mission will carry a variety of instruments, including a magnetometer and a plasma waves instrument. Scientists hope to use the data from these instruments to create even more detailed sonifications of Neptune. In the future, NASA may be able to develop new technologies that will allow scientists to record the sound of Neptune in a more traditional sense. For example, it is possible that scientists could develop a microphone that is sensitive enough to pick up sound waves in the vacuum of space. However, this technology is still in its early stages of development. Here is the sound of Neptune planet. NASA scientists have created a sonification of Pluto's plasma waves, which are waves of charged particles that interact with the planet's magnetic field. The sonification was created using data from NASA's New Horizons spacecraft, which flew past Pluto in 2015. The New Horizons spacecraft carried a plasma waves instrument that measured the electric and magnetic fields of the plasma waves around Pluto. The sonification of Pluto's plasma waves sounds like a series of chirps and whistles. The different sounds correspond to different types of plasma waves. For example, the lower-pitched chirps correspond to plasma waves that are generated by the interaction of the solar wind with Pluto's magnetic field. The higher-pitched whistles correspond to plasma waves that are generated by the interaction of Pluto's atmosphere with its magnetic field. The sonification of Pluto's plasma waves is a valuable tool for scientists. It allows them to study the plasma environment around Pluto and to learn more about how the planet's magnetic field interacts with the solar wind and its own atmosphere. NASA's sonifications of Pluto are a reminder that even though sound waves cannot travel through space, there are still ways to listen to the planets. Here is the sound of Pluto. In addition to recording the sounds of planets, NASA has also recorded the sounds of other objects in space, such as comets, stars, and black holes. These sounds provide valuable insights into the physical processes that are taking place in these objects. The process of recording sounds in space is challenging. Sound waves cannot travel through a vacuum, so the instruments used to record sounds in space must be sensitive to other forms of radiation. Additionally, the sounds recorded in space are often very faint. They must be amplified and processed before they can be heard by humans. I hope you liked the article. Thanks for watching. Please watch, subscribe and comments. Stay connected for more.